All right, we are going to. This is Friday. It's 4:24 on a Friday. I'm making a video just in case there's somebody who wants to review this stuff over the weekend. Just in case there's one view it's worth it. Okay, we're doing straight line motion problems. We did these back in the day, Unit 7. It was disrupted by Snowvid, but it's when we introduce like areas under derivatives as changes in totals, areas under velocities and displacement. Some things you got to remember that other stuff like absolute value of velocity gives you the distance if you're doing an integral. 2018 number 2, let's get started. Okay, number 2 means it's a calculator question. So get those calculators ready. Given a velocity, you're given an initial position. This is important. Don't forget about this. Because when you want to find a future position, you need to start with a known position and then find the change in your position. The change in your position is the displacement, which is the area under velocity. Finding the acceleration, this is easy. It's just v prime at 3. V prime of 3 is equal to a of 3. Literally in your calculator, you can math. You don't even have to write this stuff down. If you just write this, and then give me the answer, you'll get full credit. So ddx, why don't we alpha f1 and why not? 10 sine 0.4 t squared minus t plus 3 at 3. Boom. Negative 2.118. Find the position of the particle at time 3. Oh my goodness. Here it is. You're going to use it so often on the calculator portion. It always shows up. Sometimes shows on the non-calculator portion. But on the calculator portion, this is guaranteed to show up at least twice. So we have negative 5 plus math 9 it 0 to 3 of this guy. I want to be able to just plug it in, but I don't know how to plug that one in. 10 sine 0.4 x squared over x squared minus x plus 3. Boom, negative 1.760. Make sure you include that 0. Evaluate this, evaluate that. Interpret the meaning. Well, this is displacement. It's change in position. What is this? This is distance. This is all of my displacements, making sure they're positive. When I'm moving right, moving left, doesn't matter. That's all you need is like displacement and distance. So, boom, take this. I guess I could have just added 5. Boom. Okay, 3.239. And then distance. This is one like the old versions. You can insert an absolute value easily, but you can't insert an absolute value here. You want to, but you can't. So I'm just going to start again. 0 to 3. Math abs over num abs. Alpha f1, just so it looks pretty. 10 sine 0.4 t squared. Close. T squared minus t plus 3. Takes a little bit longer. 3.341. So there is some point when the velocity is negative because the displacement and the distance are different. Oh, gosh, I'm supposed to go to 3.5. I would have lost a point. .843 or 2.844. .737. Displacement of the particle. They even give us like units. Distance of the particle over 3.5 seconds. Of particle. 3.5 seconds. Second particle moves along the x-axis. Like that. What time are the two particles moving with the same velocity? Okay, that's not bad. When does v of 1, which is given to you, equal v of 2? Well, you need v of 2. You need another derivative position. Is velocity. Y equals, what's alpha f1? 10 sine 0.4 t squared over t squared minus t plus 3, 2t minus 1. We're going from 0 to 3.5. Might as well just adjust that window. Press on to pause, everybody. I always press graph first. Everybody press graph first. Oh, I don't know, man. Is there two? Let's adjust our Y's. Shrink it so you can see it better. Might just be one. Yeah, it's just one. Second calc, intersect 1.570. All right, let's check out the scoring guidelines. 2018 AB Calc scoring guidelines. All right, the answer worth 1 point. This is negative 2.118, 1 point. 3 points for part B. Using this, using the initial, and then getting negative 1.760. Oh my gosh, this is easy 3 points. Interpretations and answers. Gosh, displacement distance is a piece of cake question, guys. 1.570 or 571, 2 points. Oh, man, that was easy. All right, let's get to a different one. Let's go to 2017 number 5. I'm done with you. 2018. Get out of my way. 2017 number 5. Number 5 means it is a no calculator question. So we got to do all this by hand. Okay. We got two particles. A p particle with a position like that. A q particle with a velocity of that. Particle q is position 5 at time t equals 0. I give that because we need it. When is particle p moving to the left? Particle p is moving to the left when its position is decreasing. If you think about position, moving to the left would mean like going from positive to less positive to negative positions, or position decreasing means velocity is negative. Okay, so we got to find the velocity. So v of p of t. Got to take the derivative of this. This is without a calculator. Don't worry about you guys, no calculators. That's this. Now we got to set this equal to 0. We're going from 0 to 8. Can I factor the bottom? I can't. I assume that the only time is at 1. let's think like 9 minus 6 plus 10. Okay, that's positive. 49 minus 14. It's equal 1 minus 2 plus 10, 2. 4 minus 4 plus 10. Yeah, this looks like it's always going to be positive. So it's really going to be just 1. It's going to be negatives and positives. So we're moving to the left from 0 to 1. Find when the particles are moving in the same direction. Oh, man. You'd have to get question A right to get question B right. This is the velocity of P. You need to analyze the velocity of Q. This is Q's velocity. It can be factored t minus 5, t minus 3. So we got 3 and 5. Positive, negative, positives. Sign analysis. Where are you moving it? Ooh. 3 and 5 is to the right of 1. I'm just used to like 2 things surrounding. 3 and 5. Positive, negative, positive. So 0 to 1, no. 1 to 3, yes. 3 to 5, no. 5 plus, yeah. So 1 to 3, and then 5 to 8. Find the acceleration of particle Q. The acceleration is the derivative of velocity, so v prime q of t, which is equal to a q of t, is 2t minus 8 at t equals 2. We get 4, a of 2 is 4 minus 8, which is negative 4. Is the speed of the particle increasing, decreasing, or neither? Common question is speed. Speed, you could speed up going to the left if your velocity and acceleration is negative. You could speed up going to the right if your velocity and acceleration are positive. Signs of velocity and acceleration. So A of 2 is negative. I'm talking about Q. Q of 2 is positive. Speed is decreasing. Explain your reasoning. Here's my explanation. Speed is decreasing. Signs of V and A are opposite. Great. You get all credit. A lot of people try to write so much. Don't have to write that much. This is perfect. The signs of velocity and acceleration are opposite. Find the position of particle Q the first time it changes direction. All right, so Q changes direction at 3. I need to find x of 3. Now, there's 2 ways to do this. If you had a calculator, you could easily do x of 0 plus an integral from 0 to 3 of v of q. Okay, plug that in. Now, but you don't have a calculator. So, without a calculator, you could actually take the antiderivative of velocity and then find c to find your position function. 1/3 t cubed minus 4t squared plus 15t plus c would be my position of q. X of 0 is 5, c is 5. So x of t is 1/3 t cubed minus 4t squared plus 15t plus 5. Find the position at time 3. Xq of 3. Guess what, guys? And we haven't really been doing many of these, so I understand if you forget this. And if you don't watch the video, you're not going to know this. You can leave an answer like this. Okay, you don't have to simplify this. This is a calculator-ready answer. Great thing about non-calculator parts is like you don't have to worry about arithmetic. This is fine. Now, if you did it this way, you would have gotten -5 plus integral from 0 to 3 of v of q, and you'd actually had to do a little bit of work here because you can't leave your answer like this, and you can't leave an answer with like the line. You have to plug in 3 and plug in 0. You get -5 plus 1/3 3 cubed minus 4 times 3 squared plus 15 times 3. Was the initial position -5? Oh, it's regular 5. Sorry, this is a positive 5. Positive 5, positive 5. And look at that. You got the exact same answer as that, just 2 different ones. You either found C or like kind of the whole initial position is taken into account with finding C here. Blah, blah. You get the same answer. Okay. That's it. That's it. This is another easy question. Boy, straight line motion. Let's scoring guidelines 2017. Number 5. Okay, 1. 0 to 1. 0 to 1. They included 0. I don't know if, because it is negative at 0. So if you're including it, like, I don't know if they would have been strict about this end bracket. Maybe, maybe not. Those were worth 2 points. 2 points for our intervals. Oh, look at you guys. Great job. Yeah, guess what? I do that too. But like they usually don't accept this. Anyways, 1 to 3, 5 to 8. 1 to 3, 5 to 8. Boom. That was worth 2 points. 2 points for part C. Part C, the acceleration is negative. The acceleration is negative. The velocity is positive. That means speed is decreasing because the signs of velocity and acceleration are opposite. That's all you need. They would have given you credit for either finding C or putting it here. Taking the antiderivative correctly would have given you a point. And then getting your answer, which is this. You do not have to simplify it and get 23. If you did, congrats. It's not that bad, actually. I mean, 3 cubed is 27 divided by 3. It's 9. It's 9 minus 36 plus 45 plus 5. Like, you could do that. I don't want to, though. 50 plus a negative 36 plus 9. So 59 minus 36. Yeah, okay, great. Okay, another easy question in my opinion. You just gotta be prepared for it. All right, what's next? (2016) number 2. Number 2, calculator question. They're giving you a velocity. They're giving you a position. They're giving you a position at a time. That's like time 4. Be careful here. At time 4, is the particle speeding up or slowing down? Since they gave you your calculator, I don't know. Well, like, let's just do it. Like, first of all, we can find V of 4. Now, I can graph V. Might as well graph V. Maybe you'll need it for a max or min later. Max position, min position. I asked you guys max and min positions so often. It doesn't look like they're asking for max positions, like furthest right, furthest left, because I'm hard on you guys. So here's the graph of velocity. We're going from, what are we talking about? T equals 4, so I might as well get up to 4. Maybe go to 5 or something. Wow. 1, 2, 3, 4. Velocity is positive. Second calc a value at 4, just press trace 4. So V of 4 is positive. You want to find a derivative, you can go into the home screen or second calc dy dx at 4. A of 4 is negative. Speed is decreasing. Signs of V and A are the same, or are opposite, sorry. Find all the times when the particle changes direction. All right, now, boom. When does the particle change direction? When the velocity changes sign. Second, calc some intersections. I think I graphed 1 equals 0. This is from 0 to 3. Thankfully, from 0 to 3, I don't have to find all of these. I just need that first one, it seems like. Boom, just right there. Second, calc, intersect. I have to justify my answer. It's dumb. 2.707. Justify V changes sign. You like that for a justification? Jerks. That's all you need. All right, ready? I think this is like a 4-pointer, part C. What's the position at time 0? taught you two different ways to do this. Ready? My future position, which I know, my ending position, equals my starting position plus my displacement. Okay, so you could do, 2 equals some x of 0 plus integral from 0 to 4 of v. Let's just do that in the home screen. Okay, so this is 5.815. That's my displacement. You would subtract that. Boom. There's one way to get the answer. 2 minus that answer. Negative 3.815. That's my position. Or, I really think this is a 4-pointer. My unknown equals my known plus my displacement from my known to the unknown. Guess what? I got to go from 4 to 0. I'm going back in time. Like, what did I do from 4 to 0? From 4 to 0. Start minus end. 4 to 0 we know is the opposite of 0 to 4. We know this would be 2 plus, and this would be negative 5.1815. You get the same answer both ways. Pick a way that works. Part D, distance. Absolute value of velocity. That's a piece of cake. This question's so easy. These questions are so easy. I say that because I've done them so many times. If you guys practice these questions enough, you're going to be like, this question is so easy. If you just remember distance, remember displacement, the free response section is the difference maker. This is the difference maker right here. This is what's going to turn 3s into 4s, 2s into 3s, 4s into 5s. Multiple choice are just hard. It's always hard. Free response, if you know what you're doing, can be easy. All right, scoring guidelines, 2016. Particle slowing down, velocity and acceleration have opposite signs. Boom. Conclusion with reason. You just need you don't even need the values. They didn't ask you for the values, did they? I don't think they asked you for the values. They didn't ask you for, it's just speeding up or slowing down. You don't need the values. 2.707, velocity changes sign. Okay, boom. That's all you need. 3 points. An integral, they do x of 0 equals x of 4, 4 to 0. They get that answer. That's 3 points. Distance, 2 points. Gosh, it's so easy. All right, 2016. What's next? 2014. 3 more questions to do. 2014, number 4. No calculator. Let's do it. Take a little bit longer. Oh, gross. It's like a table. What's the average acceleration of train A over interval 2 to 8? That's the average rate of change of velocity. Or you could say the average A would be an integral 1 over B minus A, integral from A to B of A. But to find A, you need V of 8 minus V of 2, right? Like, that's how you can get it. V of 8 is negative 120 minus V of 2 is 100 over 6. I'm not going to do that. You don't have to do that. I'm just going to leave it like that. Oh, this question, super annoying if you actually had to find the values, but this is calculator ready. This is totally acceptable. So negative 220 over 6, whatever that is. Do the data? It does the data. Do the data in the table support the conclusion that the train's A velocity is negative 100 meters per minute at some time t from 5 to 8? Give a reason from your answer. So from 5 to 8, will we have a velocity that's negative 100? Negative 100. Well, if my velocity is continuous, By the intermediate value theorem, yes, I'd have to cross through. If my velocity is not continuous, I don't know if that's true. We are told that the function is differentiable. You'd say yes, v of a is differentiable, therefore continuous by the intermediate value theorem. You're gonna have to write it out because they don't accept IVT. I don't know. I wouldn't think they would. There must be some v equals negative 100 on the interval from 5 to 8. Just says like the function's continuous because it's differentiable. You're going to have to cross through negative 100 somewhere. At time t equals 2, the train A's position is 300 meters east of origin station. Okay, gotcha. The train is moving to the east. An expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12. Use a trapezoidal sum with 3 subintervals indicated by the data to approximate the position of the train. Okay, well, they're helping you out here because they give you at x of 2, the position is 300 east. Train is east, moving east. Okay? To find x of 12, we need the area under my velocity, the displacement. Okay, so I start with that. This is the integral expression. Now, the trapezoidal Riemann sum comes from all this data. Don't spend any time trying to calculate this. Holy cow. Okay, 1/2, my base length of 2, my heights of 0 and 100. That's trapezoidal. Plus 1/2, my base length of 3, heights of 140. You need to review trapezoidal Riemann sums. 1/2, another base length of 3, heights of 40 and negative 120. 1/2, base length of 4, heights of negative 120 and negative 150. Done. I'm done. Leave it like that. Holy cow. Try to imagine doing all that calculations. I think my students back in this day did. They're like, oh, there's so many calculations. Like, you didn't have to do it because you don't pay attention to me. That's why you did it. You pay attention to me. You don't have to do that. Second train B travels north. The time t, the velocity of train B is given by that. Okay. And at time t equals 2, the train is 400 meters north. Find the rate at which the distance between train A and B is changing. I gave you a question like this. Some of you on the test. Here's train A, east moving east. Here's train B, north moving north. What's the distance? How's it changing? X, Y, D squared equals X squared plus Y squared. Or you could say it's like A squared plus B squared. That's a Y. That means 2D dd dt equals 2x dx dt plus 2y dy dt. But the 2's cancel. So if train A is 300 meters from the station, train B is 400 meters north of the station, train D, you need to know, is 500. You're trying to find d dt. We're going to find that in a second. X is 300. dx dt is the velocity of train A at 300, or velocity of train A at t equals 2. At t equals 2, what is the velocity of train A? 100. Plus, y is 400 meters. That's train B. The velocity, that's the velocity times 2. Like, why do they do this? It's just like annoying. The velocity of B, I'm not even going to write it out, is negative 20 plus 120 plus 25. I don't even know what that is. d dt, therefore, is this divided. Can you imagine trying to do these calculate? I got so mad when we did this problem back. Like, after they released this problem, like, there are going to be students that don't know to leave answers like this, you know? And then they're just going to waste their time doing stupid calculations. I get pretty heated up about this. Oh, and watch, they're going to provide the answers on the scoring guidelines. They're going to be jerks about it. 2014. I gotta go soon. Gotta finish this. What question was this? This question. All right. Yep. Negative 110 over 3. Thanks for simplifying that, guys. Appreciate it. 1 point for that. Using the intermediate value theorem, 1 point for discussing how like negative 100 is in between. Writing down your trapezoidal sum, incorporating the position, having that was worth a point. Trapezoidal 1, finding the position, like having all the values down, worth 1 point. Implicit differentiation of distance relationship. So like having z squared equals x squared plus y squared, but then taking the derivative of it. 2 points. 1 point for your answers. Oh, look, guys, it's 160. Come on, you should have just gotten 160. Yeah, thanks. I'll get 160. 300, 100, 400. This is 125. Yeah, that makes sense. So, great. 2 more. 2013, number 2. Get out of my face. Calculator question. This is going to be easy. Blow through this. Look, they give you the velocity. They give you initial position. What is the speed of the particle 2? Speed will equal 2 when velocity is 2 or negative 2. So take our velocity, also graph y equals 2 and negative 2. Turn on. Negative 2 plus quantity t squared plus 3t to the 6/5 minus t cubed from 2 to 4. Graph y equals 2, y equals negative 2. You can do this one at a time. If you know what you're doing, you can do them both at the same time. Boom, there's 2, there's negative 2. Second calc, intersect. Enter, enter, enter. We got t equals 3.127. Ooh, I hope that wasn't the pizza place called. Second calc, intersect. Enter, enter, enter. This is how you find it. You just like go up or down to select the other ones. T equals 3.473. Part B, write an expression involving an integral that gives a position S of t. S of t would equal S of 0. This is S instead of X. Plus integral from 0 to t under V. Find the position at time 5. So yeah, I use t. You need that. You won't get full credit unless you have this expression with t. S of 5 equals S of 0 plus integral from 0 to 5 under V. So S of 0 is 10. 10 plus math 9. Integral from 0 to 5 of negative 2 plus parentheses t squared plus 3t to the 6/5 minus t cubed. I get negative 9.207. Part C, find times t for which the particle changes direction. All right, well, that's when velocity change. Justify your, okay, sure. V changes sign. That's all you need. That's your justification. We have the graph going from 0 to 5. I can get rid of my negative 2 and 2, replace it with a 0. A lot of graphing of velocity and finding intersections here, people. 1. We have a second one. Am I going 0 to 5? What is going on? I don't want to. I'm not going 0 to 5. there's twice. Never mind. Second calc, intersect. The first one. It's the second one. First one, I like to truncate. Some of you guys don't want to truncate, even though I tell you so many times to truncate. You got other teachers out there who might not like truncating. Part D is the speed increasing or decreasing. Another speed question. At t equals 4. The velocity at 4 is negative. You don't have to provide the thing. The acceleration, find our derivative at 4. The acceleration is negative. Speed is increasing. V and A signs the same. Okay. Let's see the scoring guidelines for 2013. Considering when velocity is positive or negative for speed, gives you 1 point. Your answer, those two worth 1 point. Negative 9.207. If you got that, you got 2 points. Shocking that they only gave you 2 for that. C, 3 points. 3 points? When your velocity changes sign, those two. That's worth 3 points. Great. Velocity is negative, acceleration is negative. We got both of those values. Speed is increasing. All right, last problem. 2012. I think I know what this one is. This is number 6. I think this is like the cosine of pi t. Yeah. This one's annoying. This is like more trigonometry, and so many students mess up on it. When is the particle moving to the left when the velocity is negative? You got to figure out when this is negative. How do you figure out when something's negative? First, find when it's 0. When is cosine 0? Pi over 2 and 3 pi over 2. You don't have to do anything crazy. Pi over 2 is when t is 3. 3 pi over 2 is when t is 9, right? 9 over 6 is 3 over 2. 3 over 6 is 1 over 2. Now, can you turn this into y, say 3 pi, and then like multiply by 6 and divide by pi? Yes, sure, but it's not as hard. And then 3, 9, v, let's see, if I plugged in 10, it's the cosine of 10 pi over 6. That's 5 pi over 3. The cosine of 5 pi over 3, that's the fourth quadrant, is positive. If I plug in 6, cosine of pi is negative. If I plug in 1, the cosine of pi over 6 is positive. So when we're moving like between 3 and 9. Right between that evaluate an integral expression that gives the total distance. They're not saying whether or not to they're not saying, hey, don't include an absolute value. I would expect them to say without an absolute value. But here it is, right there. That would be distance. Now, could you also, if you're ready for it, if you're smart, say, oh, take this positive displacement. From 3 to 6, I'm going to have a negative displacement. To make that a positive distance, take the opposite of it. Yeah, maybe you do that. I've asked you guys that question. What's the acceleration? All right, well, I got to take the derivative. Got to use the chain rule. So a of t is negative sine pi over 6 t times pi over 6. A, that's the chain rule, a at 4 is negative pi over 6. The sine of 4 pi over 6 is 2 pi over 3. The sine of 2 pi over 3 is positive. 2 pi over 3 is in the second quadrant. Sine's positive, so that means this is negative. Oh, I guess they want you to find it. So that's sine of 2 pi over 3 is root 3 over 2. So that's negative pi root 3 over 12. Okay, that's negative. The velocity is also negative. So V and A have the same signs. Speed is increasing. Find the position at time 4. Yeah, this is actually tough, right? X of 4 equals x of 0 plus integral from 0 to 4 of V. Okay, great. -2 plus the integral from 0 to 4 of cosine pi over 6t dt. We have to evaluate this without a calculator. The antiderivative of cosine pi over 6t is sine pi over 6t times the reciprocal 6 over pi plus c, don't need it, from 0 to 4. We get -2 plus 6 over pi sine 2 pi over 3 minus 0, because the sine of 0 is 0. So that gives me -2 plus 6 root 3 over 2 pi. Just leave it like that. There you go. There's your position. That's tricky, you know. The setup, trying to take the antiderivative. Let's see how we would get points on that. I'm going home. AB Calc 2012 scoring guidelines. All right, 3 to 9, 2 points. 3 to 9, 2 points. Yeah, they just wanted that. Yeah, I'm sure they were like thinking, hey, we should probably make it so it's not an absolute value, but it's like, no, they're cool with that. -√3 pi over 12. We already know that this is negative from the earlier thing. 3 points for that. That's great. -2 plus 3 root 3 over pi. Yeah, boom, 3 points. Using the initial condition, 1 point. Taking the correct antiderivative, 1 point. Combining them and getting the right answer. 1 point. I would say that's probably one of the hardest ones that we would have done. But that's it, guys. That's straight line motion. And yeah, I hope some of you watch this and take advantage of it. Later.